Section 1.6 is on relations. But before we talk about what a relation is, let's review the coordinate plane. You're probably familiar with this from pre-algebra. The coordinate plane is the x-axis, which is the horizontal line here, and the y-axis, which is the vertical line here. Notice that they intersect at the origin. At that point we have 0, 0, the origin. And anywhere on the coordinate plane I can list an ordered pair. And so right here I have the ordered pair 2, 3. Because the x-coordinate is 2, I've gone 2 units in the positive direction on the x-axis. That's where I get this 2 from. And then I've gone up 3 units or 3 units in the positive direction on the y-axis. 2 is the x-coordinate and 3 is the y-coordinate, and together we call them an ordered pair. So a relation. A relation is just a set of ordered pairs, and it can be expressed as an equation, a graph, a table, a mapping, or a set of ordered pairs. So here's an example of a mapping. We have these 2 big circles. One of them represents the domain. We'll talk about what that is in a minute. And the other represents the range. And each value of the domain is mapped to a value in the range. So actually let's take a look at the set of ordered pairs. So I have this set of ordered pairs here, -2, 5, -2, 6, -2, 6, 0, 6, and 3, 8. So to represent the ordered pair -2, 5, I have my x is -2, and that's mapped to the 5, so I draw an arrow. Notice that the arrow starts inside the bubble for the domain, and it ends with an arrow inside the bubble for the range. The ordered pair -2, 6 again goes from -2, but this time the arrow points to the 6. The ordered pair 0, 6 starts with the 0 and is drawn to the 6, and then 3, 8 is drawn from the 3 to the 8. Okay, so I was using the terms domain and range there without defining them. That's not really good. The domain is basically the set of all of the first terms. So you'll notice that from this set of ordered pairs, the first term is -2 and -2 and 0 and 3. So my domain is -2, 0, and 3. I don't need to repeat the -2. You'll also notice that those are the 3 numbers that appeared in my domain bubble in the mapping. The range is the set of all second terms. So you'll notice from my ordered pairs I have 5, 6, 6, and 8. So my range is the numbers 5, 6, and 8, and I don't have to repeat the 6. And if you'll notice, the 5, 6, and 8 are the numbers that appeared in the range bubble for my mapping. Generally, your domain is going to be your x's, and your range is going to be your y's. The way I remember that is x comes before y in the alphabet, D for domain comes before R for range in the alphabet as well. Notice how I wrote it with curly brackets, okay, as we did with our set notation up here. Let me go back and say something about the set notation here. That's what the curly brackets say. That is a set. The ordered pairs have parentheses around them. The x and the y are separated by a comma, and then each set of ordered pairs is also separated by a comma. When you're writing a relation as a set of ordered pairs, you need to follow that notation. I said a relation can also be expressed as a table. I did this one vertically. You could also do it horizontally, but there you have an x column and a y column, and then the numbers of each ordered pair across from each other. You can also express the relation as a graph, in which case you would just graph each ordered pair. And don't worry about labeling them, just make sure that you've graphed them in the right spot. So let's do this example. This says express the relation as a table, a graph, and a mapping, and then determine the domain and range. So this relation was given to us as a set of ordered pairs. So I'm going to write it as a table. So I'll make an x column and a y column. And then for each ordered pair, so I have the ordered pair 4, 3, the ordered pair -2, 2, and the ordered pair 5, -6. As a graph, I'm just going to plot those points. So I have the point 4, 3, the point -2, 2, and the point 5, -6. Okay? And don't connect those. Just leave them as dots on the graph. And as a mapping, so in order to do a mapping, I need two large bubbles. And the first one I'll call the domain. Sometimes you'll see an X over that instead of the domain. And the second one I'll call the range. And then in the domain bubble, I'll put my X's from the table. And in the range bubble, I'll put my Y's from the table. And then I just draw an arrow from the element of the domain that's mapped to the element of the range. So I had the ordered pair 4, 3. So I draw it like that. Again, make sure that it starts inside the domain bubble and ends in the range bubble with an arrow. I have the ordered pair -2, 2, and the ordered pair 5, -6. So there's my table, my graph, and my mapping, and now I need to determine the domain and range. So the domain is my X's. You don't have to put them in any particular order. If you want to put them in numerical order, you can. And my range is my Y's. And make sure you're using curly brackets, don't add any parentheses. Independent and dependent variables. The independent variable is the variable that determines what the output is going to be, and that's usually the X coordinate. The dependent variable is the value that is dependent on the value of the independent variable. That's usually the Y coordinate. The dependent variable, its value is determined by whatever the independent variable is. And the independent variable, often you can choose that. That can vary, that can change. Let's take a look at a couple examples here. And this says identify the independent and dependent variable for each relation. So, for the first case, for 2A, the air pressure inside a tire increases with the temperature. Think about what that's saying. As the temperature increases, or as the temperature changes, the air pressure inside a tire changes as well. So the air pressure inside the tire is dependent on the temperature. So your independent variable is going to be the temperature, because as the temperature goes up, so too does the air pressure in the tire. And then your dependent variable is going to be the air pressure in the tire. The air pressure in the tire depends on what the temperature is. For 2B, as the amount of rain decreases, so does the water level of the river. Think about what that's saying. If we get less rain, as we get less rain, the water level of the river goes down. So my independent variable, that which is going to change and is not affected by anything else, is the amount of rain that I receive. So independent is the amount of rain. And think about it, that can change. Some years we get a lot of rain, some years we get hardly any. And then the dependent variable is going to be the water level of the river. Because the water level of the river, how high the water is in the river, depends on how much rain we get. And let's take a look at these examples here. Describe what is happening in each graph. These are kind of fun. So we have our, for example number 3 here, this describes driving to school, and here's time on my x-axis. Time is almost always going to be on your x-axis, and then my y-axis is distance. So as my time is increasing, my distance is also increasing. So let's think about what this graph is saying. Well, right here at this point, right at the very beginning here, when time is 0, my distance is 0. I'm still at home. I haven't left. My distance from home has not changed. So at this point, actually maybe I'll go ahead and do this, okay, in pink, I'm still at home. In other words, no time has passed, I'm no closer to school. On this part of the graph right here, okay, notice it's fairly steep, okay? I'm traveling at a pretty good pace there because time is not increasing very much, but my distance is. Okay, so I'm on the way to school. I think I'll do that in black. Hold on. on the way to school, probably moving pretty fast. Probably not a lot of traffic. Okay, then, and this piece right here, notice right here, the graph is kind of flat. Okay, time is passing, but my distance is not increasing. I'm probably at a stoplight because I'm not moving forward. I'm going to run out of colors here. Right here, I'm continuing to move forward, okay, but at a slower speed. Continuing to school, but this time slower because it's not going up as far. In other words, it's taking me a longer time to cover a shorter distance. And then again, I'll go back to pink. This piece right here is flat. So again, I'm at a stoplight because I'm not moving forward. My distance is not increasing, but my time is passing. And then this part here, I'm continuing on to school. Okay, so think about what's going on at each part of the graph, and you can go ahead and mark it in different colors or different regions. Okay, anytime it's flat, time is passing, but the distance is not changing. Let's take a look at example 3b here. Not quite as many changes in this one. And this is talking about a change in income. So as time is increasing, my income is also increasing. Okay, and you'll notice that for this piece right here, so it's pretty steady, a pretty steady rate of change there. Okay, so my income is increasing, which is good. Okay, and then in this next part, it's very subtle, but notice that this right here, it's a little steeper. Okay, so at that part, my income is increasing more at a greater rate. My income is increasing at a greater rate. In other words, I'm making more because it's a little steeper. And then we have this section here, and it returns to the original rate. So my income is increasing at the original rate. And then at this piece right here, notice that's flat. My income is not increasing. My income is staying the same. Oops, sorry, make that green. At this point right here, my income is staying the same. Not increasing or decreasing. And then on the very last part right here, my income is increasing as it was before. Oops, as it was before. Let me make that a pink dot. Okay, so in this section, we took a look at relations and how you can express them as a set of ordered pairs, a mapping, a graph, or a table. We talked about domain and range, and independent and dependent variables, and then being able to describe what is going on in a graph.